Interval notation. Okay, first of all, to help us understand interval notation a little better, let's draw a number line. Because interval notation really just tells you or describes, I guess is a good way to say it, describes a set of numbers that are between two distinct real numbers. So in a number line, we could put 0 in the middle and go 1, 2, 3, 4 to the right. This is our real number line. And we have the negative integers going to the left. Now the furthest number to the left is called negative infinity. That's the furthest number to the left. Positive infinity would be the furthest to the right. Okay, that's the infinity symbol. It looks like a sideways 8. So interval notation would just be a way to describe a set of real numbers on the number line. Now, so the symbolism, though, sometimes you want to actually include a number in your set, in your answer, but sometimes you don't want to include. You may have been used to this. For example, if I put an open circle at the -2 and a closed circle at the +1, and I shaded everything between them, so I want to say every number between -2 and +1. So this describes x greater than -2 and less than or equal to +1. Now, you're probably used to the closed circle going with a less than or equal or a greater than or equal, and an open circle going with a less than or a greater than. Now, all interval notation, the only difference that interval notation does is that less than or greater than gets brackets. All right, so you'll get brackets. So you have brackets like that or like that. Whereas less than or equal to, I'm sorry, those are parentheses. So you get parentheses with the less than or the greater than. You get less than or equal to, greater than or equal to, you will get square brackets. So this symbolism here is inequality. And the bottom symbolism is for interval notation. So usually when you work problems out and you have to express the answer in interval notation, you're usually working out inequality problems. So let's just run through a couple here. So let's say you get an answer like this. X is greater than or equal to A and less than or equal to B. Now, on a number line, that would be like this. A and B. But now, since we have X is greater than or equal to A, we're going to have a bracket opening to the, to the right, because our values of X are greater than is to the right, less than or equal to B, we're going to have a bracket opening to the left. So the bracket, the square bracket, indicates that that endpoint is part of the solution set, the solution interval. So A is a number in our interval. We want to show that A is part of this answer, part of this interval. So this is the graph. And now the interval notation, bracket, A, comma, B, bracket. Now let me explain this. Interval notation goes left to right. So the first endpoint of our interval is at A. The second endpoint is at B. Those are the endpoints from left to right. Now we want to include A in our answer, so we put a bracket. And we want to include B as an answer, so we put a bracket. So the comma is kind of like saying we want to go from A to B, so we put a comma in between to indicate where we're separating our starting endpoint from our closing endpoint. So this is interval notation. So if they ever said, if they ever saw in a test that you want to, the answer should be expressed in interval notation, this is how they want you to write the answer. Okay, let's look at another one. So again, it's A to B. Let's look at the graph first. So A to B, x can be any number between A and B. Now, including A, but not including B. See this x is less than B? That means B is actually not an answer. But every real number up to B is an answer. And then you shade everything in between. Now watch how the graph and the interval notation really look exactly the same. So there's the graph, and here's the interval notation. The interval from A to B, including A, not including B. Okay, we'll look at another one. Now notice this one on a number line, so we'll do the graph first. A to B. But now our answer, our interval, should not include A, so we put a parentheses there. Parentheses is like an open circle, if you've done that before. And then we'll put a bracket at B because we want B to be included in our answers, and we'll shade everything in between. So x can be anything in between here. And then A to B, not including A, including B. Okay, and then finally, not including any of them. So we want to show that x can be any real number between A and B except the endpoints. All right. And then the interval notation, A to B, not including A, not including B. Now don't get this confused with an ordered pair. It looks very similar. That's interval notation. Okay, so let's graph this. Graph the interval from negative infinity to negative 3. Okay, so negative 3 is included in our interval. But from left to right, we want to start at negative infinity. Well, you don't know where negative infinity is. And we're going to end at negative 3. And we're going to include negative 3. So when you have something like this, you shade all the way to the left because we're going from negative infinity. You put an arrow because where is negative infinity? It's somewhere to the left. It's the furthest to the left that you can go. That's the graph of that interval. Let's look at another one. The interval, graph the interval from 2 to positive infinity, but don't include 2. So let's put 2 as our endpoint. So we put a bracket at 2, and since we're going 2 to positive infinity, that means we have to go to the right, because that's where positive infinity is. And we shade to the right, and we put an arrow at the end of what we're shading. Okay, then lastly, we'll look at this interval. The interval from negative 4 to positive 5. So I'll put negative 4 here, positive 5 here. We want to include negative 4, but not include positive 5. And that interval really represents all real numbers that are between. All real numbers that are greater than or equal to negative 4 and less than positive 5.